Hi, my name's Steve Gibbs. I teach electrical engineering in University of Texas at Arlington's College of Engineering, and today my privilege will be to share with you an introduction to the concept of derivatives. As we begin our focus today into derivatives, there are three concepts that are related to each other that we need to put in perspective. The first is our position or location. We're going to be going from one point to another point. And this could be on a piece of graph paper. This could be between two cities. This could be between cities in two different countries. It could be walking down the block, but it's from one place to another place. But while we're getting there, the question is how fast are we going to go from point A to point B? Is this something we should measure in meters per second? Something we should measure in inches per hour? Or some other unit? But velocity takes into the distance between point A and point B and how fast we're moving to get from point A to point B. The third concept is acceleration. How will it take when we decide to start the trip and start moving to go from zero, not moving at all, up to the speed we want to go to? We have to accelerate to get to the velocity that we want to travel at. When we reach our destination, there's going to come a point where we're going to leave that velocity and start slowing down again. Because when we reach our destination, what do we want our velocity to be? It should be zero. So put stop signs along the way, put traffic lights, put road hazards on a trip across town, and we'll have a number of times where we are accelerating to get up to speed, or we're using negative acceleration or decelerating to get back down to a lower speed. And these are all calculations that lead to our instantaneous velocities, how fast we're going at a given moment in time, or our average velocity, how long it takes to go all the way from point A to point B. So obviously the question is, what is a derivative? A derivative is a measure of how fast something is changing. Acceleration is how fast velocity is changing. Velocity measures how fast we're moving from one location to another location. Okay, let's look at the math that describes this kick. We see it kicked, we see it peak, we see it drop into the goal. Now let's see what we can do with derivatives to explain how high it's going, how long it takes to get there, what its velocities are, and we'll go from there. As we watch the kick, the ball started at the ground, followed an arc that peaked at about 11.25 meters, and then proceeded back to the ground again. It took 3 seconds to make the entire trip, which means it reached its peak at half of that time, or about 1.5 seconds. Okay, now we've set up the problem. We've got a soccer ball going through the air. We know that it has created an arc, moving through that arc, and we can calculate some parameters related to it. In the next session, we'll look at what those parameters are and how to calculate them. See you in a couple.